Hello, beautiful people. It is Monday, April 20th, and thank you for tuning in to the Bowman Show. Today we have a unique, let me say it again, unique interview today with a neuroscientist. Do you believe it? How am I friends with a neuroscientist? I know it doesn't make sense, but just tune in. It's going to be really cool. We're going to talk about the neuron and how it relates to. Can someone play it for me? You got that right, boy. Oh, that was a doozy. But yes, a toilet. Can you believe it? A toilet. How neurons in our body relate to a toilet. Stay tuned. It's going to be a good one. We are live today with one of the most famous doctors in American history. You got that right. Doctor. Wait, what's that? Doctor. Dr. Canuck.
Woo! Woo! Yeah!
Woo!
Mr. Bowman, thanks for having me on the show. It's been a long time since I've talked to you last.
Oh, I know. Well, if Mr. Knock's knocking, you better answer the door. He's going to bust that damn thing down. So I figure I have to have you on the show.
That's right. It's lucky you caught me now because I'm in between surgeries. I've been doing a lot of DBS brain surgeries here at my neuro clinic. Deep brain stimulation. We're helping a lot of patients here try to improve their lives by trying to find ways to allow them to perform better at whatever job or skill they need to perform better at by stimulating their brain with electrodes, sending electrical pulses into their brains to increase their motor movements and stuff, and obviously make their lives better.
Dang. I tell you what, I'm glad I don't have that job. I don't have steady hands here. I'm shaking all over the place. I'd be triggering something, kicking legs all over the place, kicking hands, utensils flying. My aide will be dead. Who knows what would happen? So I'm glad that job's for you.
Yeah, and the interesting thing, too, is they're awake when this is going on.
Oh!
So, yeah.
Oh!
Very, very rewarding. Very rewarding.
I'll say. You got to get a video of that sometime. Maybe I can put it on the classroom page. That would be pretty cool.
Will do.
All right, Dr. Canuck, I just wanted to have you on the show today because you are the best in this field. You are by far the best. And I want to talk about, first off, what is a neuron? Okay, and then we'll get into the 3 types of neurons. And then we'll get into some of the functions, parts of the neuron, and how we can maybe field some examples of the parts and functions of the neuron. And then ultimately how it relates to a toilet. Because I think that's the best way to understand how a neuron fires and what its job really is. All right? So what do you got, Dr. Knott?
Well, we can start with what a neuron is first. I believe that's, when you're building anything, you want to start with the foundation, and we got to have a foundational understanding of what a neuron is. Obviously, there are building blocks. There's cells specialized to receive, process, and then transmit information to other cells. And we can start with that 3-step process right there to kind of understand what types of neurons there are in our body. So you have your receptor neurons, which is your sensory neurons. So we have a stimulus from the outside world that is being transduced by our sensory organs, whether that be an olfactory organ, auditory organ, hearing, whatever. And that message is then transmitted via those sensory neurons to your brain. The neurons that are located within your brain are called interneurons. They're kind of like the middle guy. So your sensory motor neurons don't communicate directly with one another. The message goes to this middle guy first, interneurons, which then processes that information, decides what's important, and sends it to your motor neurons. And then voila, we have action. We have behavior. We have throwing a football. We have kicking a football. We have thoughts. We have language, all those human behaviors.
Nice. So you're pretty much saying that the neuron is the messenger. And you know what they say? Don't shoot the messenger, right? Don't shoot that
right.
messenger.
Don't shoot the messenger.
So we have the sensory neurons first. They're picking up that stimulus, right? They're picking up that information from the outside world, whatever it might be. So it might be hearing, it might be you might be seeing something, you might be smelling something, you might be tasting something, and that sensory neuron is taking that information directly to the brain, right? Okay.
Yep.
So then the inner neurons, that's like the middleman, right?
Yep.
Oh,
Exactly. It'd be like the middleman.
you know what?
Nobody really pays attention to the middleman.
No.
But he's there. He plays an important role, right?
you know what, Doctor? I hate the middleman. I really do. It's like, let's just get to it, right? Let's just drop whatever we're doing and get right to it. Get that middleman out of there. But hey, I get it. There has to be one. So that's the inner neurons, right? They're connected mostly in the brain, right? Okay, that's what I thought.
And you need that. You kind of need that middleman because you have all that sensory stimuli coming into the brain, and we don't want to be sending all that stuff out, because if we send all that stuff out, it's like overloading a computer, man. We're going to be doing all different kinds of wacky things that would be probably deemed not socially acceptable, breaking norms in society. We don't want to be doing that, right?
Who knows what's on people's computers? We don't want to know. We don't want to know. Keep that information to yourself, right?
Yeah, exactly.
So then you got the motor neurons, right? So the motor neurons are sending that information to the rest of the body. So this is our reactions.
Muscles, glands, joints, all that kind of stuff.
Yeah.
So, yeah.
Nice. So that's like performing a task. You said football. I'm a big football guy. I'm glad he said that.
Yep.
I'm glad he said that. Go Pack, go, baby. Woo!
Go Pack, go. Go Pack, go. Super Bowl this year.
I hope so. I hope so. This is why I like you, Dr. Knight. This is why I have you on the interview today.
All right.
All right, Doc K. I just want to get into it right now about the neuron. All right, so we're going to talk a little bit about the parts of the neuron and maybe give some examples that the kids can relate to. I think that's a cool and a relatable way to understanding the neuron, its parts, its functions, and how it works in our body, right? So where are we starting off?
I agree.
Yeah, where are we starting off first, Doc?
Well, we just obviously start off in the receptor sites, which are called dendrites. Okay, so we're receiving the sensory information, and the dendrites are kind of like branches of a tree. They're receiving that sensory information, and what's interesting about it is they're selectively permeable, which that means that they're kind of weeding through that sensory stimulus and deciding what's important. Because once again, we don't want to overload the computer, correct?
That's true.
What happens when we overload? It crashes. We have problems. So they're selective in terms of what they receive.
Oh, all right. So they're cutting out the BS, right? Only the specific important stuff.
Exactly.
Okay. So the dendrites are almost like wide receivers, right?
Yeah, they're almost like wide receivers. They're like Double D, Donald Driver, Don Hudson, Greg the Legs Jennings.
You name it.
Those great Packer receivers, right?
Go Pack, go! Go Pack, go! Go Pack, go! Yeah.
Go Pack, go, baby. Let's go.
They're out there catching balls. They're running to then. Actually, they got to get the information from someone, right? They got to get some intelligence, right? They have to understand the play. So who's giving that? What part of the neuron is giving out that information and is calling all the shots?
Well, once they receive that information, it goes to what is called the cell body or the nucleus. And I can make another relative example for you, or connection here for the younger folks.
Okay.
It's kind of like the mail system a little bit. The mail comes in, and what do those people do in the mail distribution center? They sort the mail first, right?
Yes.
So even though those dendrites are selectively permeable, the nucleus also sorts through it too, decides what is the important information that then needs to be sent down the axon, to the axon terminals, which we'll get to later on. So what information is important, sorts that mail out, sorts that sensory information out, and then decides what needs to be sent on.
Gotcha. So it's almost like the cell body. That's like where the nucleus is located. And the nucleus is like the man who calls all the shots. He's like that quarterback, Macklin Ayers. Perfect example here. So he's like,
that is a perfect example. Yes, it is.
Yeah, so he's calling all the shots. He's like deciding, what's good play, what's not a good play. If it is a good play, we're going to send this down the axon, right? Okay, that axon is just this long branch, right? This long terminal that's carrying information to potentially, well, we're going to get the axon terminals first, but then potentially the next neuron. All right, so that axon's almost acting like a running back. So you got every quarterback has a great running back, right?
Exactly. And that running back, to help you with the connection here a little bit, you want that running back running north and south. You don't want them zigzagging east and west, right?
No, we ain't wasting yards here. We're going.
No, we're not. We're
Four.
going straight down, forward. We got to get that message there now.
We're getting 6, baby. We're getting 6. We ain't stopping.
Yeah. So once that threshold is reached,
okay.
So once that absolute threshold is reached, so obviously that energy is negatively charged, and once that positive energy outnumbers or exceeds that negative energy, bam, that running back takes off. He gets the ball. He runs down that axon. The message is sent down that axon to the axon terminals.
Damn. So that's like shooting it like a rocket. Right?
Exactly.
That's like number 33 back in the day from Tri-Valley, Bowman character. I don't know, but whatever. Okay, that was years ago. But that's like Jake Ramberger slicing down the field.
That's another good example.
Yeah. North and south. He ain't going east and west. He's going straight at you. He's going to score, no problem. Right?
Mm-hmm.
So then after that axon carries that information, where does it go to next?
Well, it then goes to the axon terminals. So the terminals are what houses neurotransmitters. Those neurotransmitters are what are chemical messengers, or I should say, the synaptic vesicles within those axon terminals house our neurotransmitters. And those neurotransmitters are chemical messengers like norepinephrine, dopamine, serotonin.
Whoa, you're throwing a lot of terms
serotonin
at
and
it.
dopamine are associated with happiness, okay? And different bodily functions and feelings. And once that message gets there, it sends a message to those synaptic vesicles in terms of what neurotransmitters are to be released and received by that next neuron, the next dendrite branches, on its way to its final destination, okay? Whether that be to the interneuron or the motor neuron or whatever.
Whatever it might be, yeah.
Yeah.
So you're saying pretty much every single part of this neuron is extremely, extremely important to carry messages to the brain, away from the brain, connecting neurons together. Mm-hmm. Every single part of this neuron is significant.
Absolutely. It's significant to our actions as human beings. It's significant. Obviously, actions and behaviors are kind of very similar, but also our thoughts too. Our ability to speak and communicate with one another. So everything that's involved with being a human, it's extremely important. And if there's damage to a neuron in some capacity or another, which we'll get into it later on when we talk about the toilet example, it could greatly impact us psychologically, cognitively.
Okay, all right. So we're saying pretty much that the neuron pretty much controls everything we do that we can think of and that we can't think of.
Mm-hmm. Absolutely.
Wow. That's a lot of wow. That's a lot of things the neurons are responsible for.
It's very complex. It is.
I'll say. So these dendrites, okay. So these axon terminals. These axon terminals reach out and branch out to connect to other dendrites to other neurons. Correct?
Mm-hmm. Yes.
Okay. So they're a little frisky, right? Kind of reaching out to all these other different neurons, connecting the other ones, right?
They are, and it's a complex process in itself. You think it'd be very simple, but it's actually a complex process because you have a little bit of, it's called the synaptic cleft or the synaptic gap between those axon terminals and the next receiving dendrite or the next receiving neuron. And when they release those chemicals, they have to bind to those dendrites.
So it's like a perfect fit.
Key. It's like a key fitting into a lock. If it's not the right key, it's not going to send a message. So it has to fit perfectly. And they're also very resourceful, so they don't waste those transmitters. And that's a process called reuptake. So if neurotransmitters are not needed and those keyholes have been already filled, they reabsorb those neurotransmitters and they don't waste them. So these neurons and the process of neural transmission is actually very resourceful.
Wow. Okay. I got you. So it's pretty much a perfect fit. It has to be a perfect fit to send this information to the next neuron.
Not necessarily a perfect fit, because a lot of times, when some people have trouble and they don't produce enough of a certain neurotransmitter, Doctors will prescribe medications that are very similar to that neurotransmitter, and they are similar enough to fit the keyhole, but they're not an exact fit. Okay?
I got you.
So,
Wow. Well, I'm really glad you're here, Doc, to explain all this. This is awesome. This is really good information that the kids can understand, especially with the key. That was perfect. Perfect analogy. I like that. I like that a lot. All right, Doc. So now we're getting the last part of the neuron that I want to talk about today, and that's the firing of a neuron. And the firing of a neuron, which I think was unique and that I got from you actually, is that how it relates to a toilet flushing. So walk us through the steps here. I mean, this is something that the kids can grasp and that they can understand to really understand how this neuron fires. So what do we got? Where do we start?
yeah, as obviously, it's when we're talking about education, relativity is very, very important. So let's make it relative for the kids here. So obviously, we'll start with the all or none principle here first. So obviously, the all or none principle we're talking about with the neuron is when the action potential is released, it's released. So it's either all of it released or none of it released.
Okay.
So once that absolute threshold is reached, all of it is released. Okay. So how can we relate that to the flushing of a toilet? So you think of the toilet itself, and obviously we can all relate to the bathroom because we spend a lot of time in there.
Oh yeah, especially
we may not want to admit it, but we do spend a lot of time in the bathroom.
yeah, all those kids are saying, you know what, I'm going to get out of Mr. Bowman's classroom. I'm just going to take the hall pass, say I'm going to the bathroom, actually just walk around the halls and say, you know, just walk around with my boyfriend. So, right?
Exactly. And if they do make it to the bathroom, they might actually not even flush the toilet. But anyways.
Probably not.
Yeah. So let's just hypothetically speaking here, they actually are using the bathroom.
Okay.
So
very rare this is happening.
Yeah, they use the bathroom. So the all or none principle. So we're thinking about the bathroom, we're thinking about the toilet. So when you use the toilet, you deposit in the toilet, then you flush the toilet, right?
Mm-hmm.
Okay?
Yep.
So either you flush the toilet or you don't flush the toilet. If you cross that absolute threshold, which is actually flushing the toilet and pressing hard enough the handle of the toilet, okay, you have reached that absolute threshold, and at that point, then obviously the action potential is released, and obviously the deposit will disappear. But then the question is, what if, you know, and I get this all the time, you know, when I'm talking to students all the time, and well, okay, so the action potential disappears, the deposit in the toilet, whatever it may be, disappears. But what if it's clogged?
Oh,
Yeah.
What happens if that's clogged?
What if your wife or your children use too much toilet paper and it's clogged?
Or if you
we've all had that issue before, right?
Yeah, so or if you just ate a huge cheesesteak from JoJo's or something crazy.
Yeah, exactly. Huge cheesesteak, or you had about 17 popcorn chickens for lunch that day, whatever it may be, right?
Whatever might happen down there.
Exactly. So what if it's clogged? Well, if it's clogged, then we're going to have some issues because that message is not going to be sent, right?
And you're leaving a bad prize, like a little present for the next guy that comes in there. He's gonna be like, what's going on down there?
Yeah, exactly. So we're going to have some weird actions, or some weird behaviors, or something happening, or you're not going to have some muscle movements that are appropriate to that situation, whatever it may be. But anyways, we're not going to talk about that right now. We're going to talk about the whole process of it actually working. It's not clogged or anything like that.
Let's just say it's working perfectly fine, right?
Yeah, everything's working perfectly fine. So all or none principle, everything's flushed, everything has passed through the axon, the message is sent through, and
there's no stopping it, right?
There's no stopping in terms of the toilet. It's all sent to the septic tank or whatever.
Yeah.
Or the message is sent to the next dendrite.
So not even Wonder Woman with her golden lasso can like pull this thing in and stop it from freaking going down the hole. There's no way stopping it.
Exactly. There's no way stopping it because that's the direction of impulse. The direction of impulse can't come back.
Yeah, that's so next term there, right?
Yeah, the flow of the water is one way only.
Okay.
It doesn't come back the other way. Yeah, I know. Once again, if it's clogged, but we're not talking about that right now.
Yeah, so even like driving a car, I know all you kids, if you see it one way, it's like, you know what, maybe there's no cops around here, so I'm going to take a left here when it says one way to the right. I'm going to just break the law a little bit. No, there's no way of that you're going to change that direction, right?
Exactly.
Okay.
It's just one direction, right to the next dendrite. That message needs to be sent quick. Remember that running back example, north and south. We got to get there right now.
Okay, we're moving to sticks, baby. We're moving to sticks.
Moving to sticks. Once we move those sticks, though, right, we got to recharge.
Oh,
okay, we got a first down, right?
First down again. First down again.
First down again. We got that refractory period, right? So this period is when we're talking about neurons here, specifically, is the recharging period. So after that action potential happens, we have the direction of impulse all the way down through all that happens. The deposit is in the septic tank now. Now we have a recharging period. So the toilet starts to fill back up, right?
Yep.
This is where the toilet bowl starts to fill back up. The pod itself starts to fill back up. The chamber still fills back up. And it sets itself up for that next action potential. Okay, so we have that negative energy all building back up until we have that positive energy that would obviously outweigh that negative energy to send that next action potential.
Okay, so the refractory period is almost like, well, these kids probably can't relate to this at all, but those old cameras that you got to recharge back up. You can't take another picture until you wind that son of a gun back up and ready to take that picture, right?
Exactly. You know, you just can't pop another one off right away. You got to wait for that puppy to recharge before you can take another picture.
I got you. Cool.
That's a great example.
Nice.
Great example.
I like that.
But you know, we got to understand what that absolute threshold is first.
Okay.
Correct?
What's that? Pleasure.
Because they might not be knowing what and completely understanding what exactly that is. Okay? So you're thinking about it. When the neuron itself is negative in terms of it's made up of ions, proteins that are negative in nature. Okay?
You got to get those positive, right? You got to get those positive.
Yeah, negative and positive. So it's negative in nature. It's kind of just waiting there. It's waiting for that positive pressure. It's kind of like Newton's third law. You got to have that positive pressure before you have action.
You got to get that peer pressure going. Get people going, right?
Exactly. So we got to get that peer pressure going. So we're waiting for that positive pressure. So we have those sensory messages coming in. Okay, that's kind of providing that positive energy. And it's exciting those neurons a little bit, okay? So you have those positive ions.
Oh, we're getting excited, baby! Woo!
Yeah, getting excited, right? And once those positive neurons exceed those negative neurons...
Oh, so you're saying we got more positive people than negative people.
Exactly.
That's what we need all the time, right?
Yeah, exactly. It's like doing a vote in class. You know, you're waiting for that majority, right?
Yep.
Once you have that majority, then you can send a message, correct?
Yep. We're letting the train roll, baby.
We're letting the train roll. So once the majority outweighs the minority, okay, that message is sent down, okay, or that message is started by, okay, the neuron. And it's sent down to absolute threshold. So once that positive pressure from your fingers, we're relating this to the toilet now, once that positive pressure from your finger pushing against the toilet handle exceeds the negative resisting pressure of the handle itself,
yep,
then the message is sent. The toilet flushes, right?
Yes. So you're sitting there, you're saying, wow, this thing stinks. It stinks.
It stinks, is right.
I'm getting this thing down the drain as fast as I can. So I'm going to hit that trigger as fast as I can. Get the positive portions going. Yep. Yeah.
And sometimes we got to do it early because of a courtesy, right?
Yeah, we do.
You know, we got to do it early because of that courtesy flash.
Oh.
You always hear that like, hey, give me a courtesy flush on that, right?
Or the spray, right? The PooPourri is like, oh, it stinks. You got to spray before you go. It's a new spray. I know you guys might not know that, but it's PooPourri. It's actually one of our sponsors for the show. So there we go.
It is one of our sponsors. That is correct. Yeah. But anyways, once that pressure is reached, positive pressure from your finger outweighs the negative pressure from that resting potential, which is the handle itself, just there without any pressure whatsoever.
Oh, so the resting potential is just waiting to be fired, right? It's just sitting there.
It's just sitting there waiting. Exactly. And that kind of takes us into our next thing, because that resting potential is after that recharging period. It's just resting. It's waiting. Those negative ions are waiting to be charged.
So that's
waiting to be charged.
So
it's a resting state with no action whatsoever.
Yeah.
It's waiting to be charged.
So that thing's just sitting there, savoring, stenching up the bathroom, just waiting to be flushed, right?
Exactly.
He's like, take me to my home. Take me to my home.
Take me to my home. Okay. And you know what? That varies in terms of how much time you need to spend in the bathroom. It varies from person to person.
Well, that does. Yeah, it depends who we're talking about here.
It does. It depends on who you're talking about, and a lot of times, women would say that men spend way too much time on the toilet.
Well, yeah, you're right. You're right.
yeah. We like to take advantage of that resting potential.
Well,
but anyways,
who wouldn't? Who wouldn't, right?
Yeah, exactly. Especially in these times, right?
Yep. Especially these times here.
So, anyways, back to the neuron here and the toilet. So the action potential itself is the negative balance that can be easily upset. So when the cell becomes excited, it triggers the action potential itself. Okay, and we kind of talked about that already, or itself. Which reverses the charge and causes the electrical signal to race along the axon. However, okay, how do we relate that to the toilet example? Okay, so the water itself and the deposit in the toilet, whatever it may be,
who knows?
Making their way down the drain to their final destination would be the action potential itself. So once we flush the toilet, and the deposit that's in the toilet, whatever it may be, makes its way to its final destination, septic tank, whatever you want to call it, would be the action potential itself.
Okay, so this thing's racing about Mach 5 down its drain, no stopping, no one getting in the way, and if it does, it's getting mowed over, no problem.
It's mowed over, exactly.
Okay.
But that initial part of it, is called depolarization. So depolarization is the initial movement of the action potential, where the action passes from the resting potential, so that state of nothing happening whatsoever in a cell body, into the action potential. Okay, so that transition from the cell body, so when it's passing that message on to the axon, the action potential, is called depolarization. So that's the initial flush itself. So once that absolute threshold is reached, the positive ions exceed the negative ions, that flush of water into the toilet bowl, that is the absolute threshold, or what is called depolarization, because we're depolarizing, we're changing from a negative to a positive action.
Okay, so this depolarization, this is almost like when you get the weed whacker out, you see all the weeds just standing up straight. You're just like, oh, your dad's yelling in your ear. He's like, get out there in the yard, trim that puppy down. Okay, so I'm sitting there pulling away. And right when I hear that thing kick, that's depolarization. Right when that kick happens, that engine's starting. There's no way these weeds stand a chance in my way. My dad's yelling in my ear. He's like, get that job done. I'm getting it done. Right when I pull start this thing, it's going. It ain't stopping.
Yes, Mr. Bowman's like, hey, my boy is getting the job done.
Yes.
He's getting it done.
We're not stopping until that job gets done, right? I think that's a song.
Exactly
I think it's a song. I don't know what song it is, but it's not stopping.
It's getting it done,
McLenair is in the end zone, touchdown, spike the ball, game over. That's it. District 3 title. We can do it, no problem.
Exactly.
Yes, I like it. Well, hey, Doc, I really appreciate you being on the show today. This interview was great. I think this was something that we needed to happen here for our psych class, right? This is the first ever The Bowman Show episode for our psych course. And I love that you're on today. It really hits home for the kids at home. You know, these are tough times, but hey, we're tough people. We're tougher people. We're positive. You know, we're having a great time here. We're having fun. So, is there any words of encouragement that you can have for these kids here at home? What do you think?
Yeah, absolutely. Obviously, these, like you mentioned, these are tough times. And the only thing that you can obviously do during these times is stay positive. Even though it's tough to do that, is to stay positive. Positive thinking breeds positive results. if you let those negative thoughts creep into your mind, it result in negative actions. It will.
Yeah.
So the only thing you can do is think positive and stay positive and encourage others to stay positive. And that will ultimately result in positive thinking and positive results. Because if you think positive, it will result in positive action.
So, Doc, you're saying pretty much that this action potential should be the positivity in our lives right now. We're going to punch through this wall that's trying to stop us right now. We're going to just strive to be our best. And we're not going to end or settle for anything less, right, Doc?
Absolutely. You know, as Maslow said, I'm going to use a psychological theory here.
Maslow.
Maslow said self-actualization. You fulfill those bottom levels of our initial drives of food and shelter and all that stuff. We want to achieve self-actualization. The only way we can do that is by staying positive and encouraging others. So I would just encourage everybody, specifically students at Upper Dauphin and other neighboring school districts, to do the same, to stay positive and encourage others, and we'll get through this together.
Doc, I'm really glad you brought that up. Maslow's hierarchy. We just talked about that in my course. I think these students really got that right now, especially you throwing that little tidbit in there. I loved it. That was great. Well, hey, Doc, I appreciate it. I love the information that you're giving the students today. This was awesome. This was great. The neuron, we explained the 3 types of neurons. We explained what a neuron was. We explained the parts and the function of the neurons, the examples of it, and also we explained how this neuron relates to a toilet, how this fire, the firing of a neuron, this is happening, in a fraction of a second, right?
Mm-hmm.
Yeah, and there's nothing stopping
Absolutely.
it. Yeah, there's nothing stopping it. And I think this interview was probably one of the best. This was really great, Doc. I really appreciate this.
Absolutely, and I appreciate you having me on the show, and I hope the audience takes this to heart, and they can apply it to their lives, and also apply it to other lives also.
Yeah, we're just gonna keep this. We're gonna keep this boat moving forward, right? We're not gonna stop this thing. This is gonna be
Absolutely.
This is gonna be good. This is gonna be in a positive way moving forward. Well, hey, Doc, I appreciate it. Thanks a lot. Can we get a woo-hoo for the crowd today?
Woo-hoo!
Woo! All right, sweet. Thanks, Doc.